All the proofs you guys did yesterday, in class and for homework, what was always given? I had a parallelogram. Today, prove to me it's a parallelogram now. Okay, prove to me this quadrilateral is a parallelogram. And this is not in your notes, and I don't want you to write it down. I think it's a lot easier for me to visually show you what makes a parallelogram. Okay. So I have 5 different quadrilaterals up here. There we go. 5 different quadrilaterals. Here's what your diagram should look like for it to be a parallelogram. Ready? Diagram 1. Can you do this? What did I just do? No, I'm just saying, if you can show me this, it's a parallelogram today. What did I just show you? What is this right here with the markings? Opposite sides are parallel. So if in a proof today, you can get both pair of opposite sides parallel, you have a parallelogram. All right, well, what if you can't do that? All right, there's other options. Maybe you can do this. What are you showing on this one? Opposite sides congruent. Maybe you can do that. All right, well, maybe I can't do either one. So maybe I'll do this. Notice, it's got to be both pair. If you only have this, no go. No go if you only have one pair. You got to have both pair. What are some other options that make it into a parallelogram? Well, you could have this. What if you can do that? What am I showing you on that one? Well, more diagonals bisect. So if you can get both, not one, both diagonals to bisect each other, it's a parallelogram. What am I just showing you here in these 4 options? Your properties, aren't I? If you can show me one of your properties exist, you're good. There's one special case, though. One special case. If you can do this today. What's that right there? One pair congruent and the same pair parallel. If you can do this, I call it the special case. If you can show one pair of opposite sides parallel and congruent, it makes it a parallelogram. So today, here are your 5 options to make it into a parallelogram. I'll tell you, showing opposite angles, probably not going to happen. Okay, it's a method. It's a method, so I wanted to show it, but it's going to go down to these 4. All right, these 4. So before I just threw you into a proof today, I wanted to make sure we get plenty of practice on figuring out why it is a parallelogram. All right, so you got your diagram up there. I'm going to give you a couple facts in each one, and I want you to tell me, hey, is this good enough to say it's a parallelogram or not? All right, so number 1, SPX and TMX. Let's mark those angles congruent. And again, unfortunately, you're going to have to use that same diagram going back and forth. So SPX and TMX. I did it again. Stop right there for me. Can you guys also imply something else is true if you know those angles? I hope so. I hope so. If those angles are congruent, what else does that mean is true? Don't say anything. Look at it. If those angles are congruent, what else has to be true? We got to get to this point because we can't do the proofs like this. If those 2 angles are equal, what else is true? 20. Any idea what else is true here? Now, that has to be in the same triangle for you to say that. They're alternate interior, which means what? Which lines are parallel? That means, guys, SP and MT are parallel because those are alternate interior. We have to get that on our own today. Look at the other pair that's congruent. TPX and SMX are congruent. I'm hoping you can conclude something from this as well. If those 2 angles are congruent, what else does that mean? 8. What else do I have?
That means that SM and PT are parallel.
Good job. Is this a parallelogram?
Yeah.
Is this a parallel? Based on these two pairs of angles being equal, is this a parallelogram? Yes. So yes. And then let's start getting practice what we're going to write in our reasons column to end this proof. End all our proofs today. Yesterday, you started out by saying parallelogram implies the property, right? So if you want to prove a parallelogram today, flip it. Tell me what property is here. What property are we using? What property are we just showing here? Opposite sides parallel implies a what now? Okay, that's what we're going to do. We're going to flip it if I want to prove a parallelogram. All right, these next ones go a little quicker than that. Ready? Sx and xt are equal. So are Sm and pt. Is this good enough to say it's a parallelogram? Is this good enough? What do we think? Absolutely not. You need both pair of opposite sides congruent or both diagonals to bisect each other. So this one's a big no spot right here. That's not enough information to say it's a parallelogram. All right, let's keep grinding. What do we got? Px, mx, sx, tx. Good enough to say it's a parallelogram. Yes. What? Because the diagonals bisect each other on this one. Good. Diagonals bisect each other implies a parallelogram. All right, last one. SP and MT are congruent, and they're also parallel. Look at that. Is this good enough?
Yeah.
This is, everyone see, this is my special case I talked about, right? So yes, but I'm not going to write special case implies a parallelogram, unfortunately. Sorry. So what, describe to me in your own words, what's happening? What do I have? One pair of?
One pair is parallel and.
Okay, we're missing a key term here. I just can't say one pair of sides. They have to be opposite. Correct. So ready? A pair or one pair, doesn't matter, a pair of opposite sides are what? Congruent, and they're congruent and parallel implies a parallelogram. Yep. That's our new special case. A pair of opposite sides are congruent and parallel. Not both pair, because that's not true. Just a pair, one pair. All right, ready to do some work in your group? I marked your diagrams for you in these next 8. All I want is a yes or no to go quick. All right, a yes or no from your group. If they're a parallelogram or not, I do not need an explanation. Go ahead. Or be ready to give me an explanation if you get called on it. But don't write it down. Let's save some time.
No. Number 11 again. I can read.
All right, here we go. First one, yes or no here. 13?
Yes.
Why?
Diagonals
There. Good. You got it. Thanks, Kevin. Perfect. 4. Next one. No. One pair doesn't do it. I need both pair. 5. Next one. Don't have one. 7. Next one.
No.
No. Definitely not enough information there. 22. Next one. Yes. Why? Darn right they are. 23. Next one.
Yeah.
Yes. Why?
Opposite sides parallel.
Good. We have to identify. Those are alternate interior. So that makes opposite sides parallel. Perfect. Yes. How about 12? 11. Don't have one. Don't tell me we don't. 23. Yeah.
No.
Oh, no. Good. Need both pair. Had me going there. Next one. 4. Why?
A pair of opposite sides are congruent and parallel by parallel.
Great. 8. Last one.
No.
No. One pair doesn't do it. All right. Any issues before we start a proof now? Let's do it. Alrighty, 1 congruent to 2. And 3 is congruent to 4. Prove to me that this is a parallelogram. So I need to make it look like one of my diagrams I showed you at the beginning. First thing, does everyone, in the given, see how it says PQRS is a quadrilateral? It doesn't have any properties. Okay? It's just got 4 sides. That's all it's telling you. It's got 4 sides. So don't think you see the word quadrilateral, oh, opposite sides are congruent, or no. Quadrilateral doesn't have any properties. All right? It's just telling you it's 4 sides. All right, 1's congruent to 2, 3's congruent to 4. Do we see anything that we should know is happening right now? We've done this a couple times today, right? If those angles are congruent, that should tell you what? 7. If those angles are congruent,
QR and PS are parallel.
along with, keep rocking.
PQ and SR.
There you go. Both pair of opposite sides are parallel. Isn't that what it means? So I need to write that. PS parallel to QR and PQ parallel to SR. Ooh, who's got the reason why? Who's got the reason why those are parallel? Ooh, we never wrote that down yet, but 21. Why did we say those were parallel? Okay, Chloe, you're missing one word there, Scott. Alternate interior angles, they have to be what? Congruent, right? Add in the congruent word, because alternate interior by itself doesn't make parallel lines. They got to be congruent. Alternate interior angles imply parallel lines. Is this a parallelogram, or should I do more? I should? Is this a parallelogram right now, or should I do more?
Yeah, okay.
Is it? You guys, is it a parallelogram? Yeah, it is. I know this is not our norm 8, but got to start you off easy. You guys, how do I know it's a parallelogram? 1, how do I know it's a parallelogram there, George?
Opposite sides parallel imply parallelogram.
Darn right they do. All right. We wish they were all this easy, right?
Yeah, but
Correct. You know, this one's great and nice and neat, and, you know, after this, it's just going to get chaotic. Any questions, though, here? Why, Via? What type of class are you in? Above average, right? There you go. Okay, the AB for above. Not that it really means that, but it can. All right, let's go to this one. So we're going to get a little tougher now. Whoa! I'm giving you a parallelogram and prove one. All in the same one, huh? What am I thinking? And I give you a pair of congruent segments. AE congruent to CF. And this bad boy in the middle, I'm sorry, the whole thing's a parallelogram. So all the properties can be applied to the big quadrilateral. Everyone see the one we're trying to make a parallelogram, the one in the middle. So your thinking right now is, okay, how can I get congruent sides or parallel sides in the one in the middle, DFEB, DFBE? All right, because that's what you want to try. You want to try to get congruent sides or parallel sides in your figure. And for some reason, they gave me AE equals FC for some reason, huh? Oh boy. How can I get a pair of congruent sides or a pair of parallel sides here? And remember, the outside figure is a parallelogram. Ooh. A little over a minute. Discuss it. Here you go. Discuss it. Contribute or listen. Be an active listener. Try to get me a pair of sides that are equal or parallel. Come on. There's a reason I gave you AE equals CF.
It has to be isosceles and
Yeah,
stuff.
you can prove these lines. And the triangles
You're like
That's what I was thinking it'd be like
Well, I started to stay like
Then after that, we can just do the special subtraction.
but like what then I see like it's gotta be an isosceles.
Yeah.
But I don't know. Because then F will be supplement F, which is already equal to B.
All right, let's do this. Let's do this. I don't need a full, complete one. Did anybody get any sides congruent right away? No, I wouldn't say right away, but in a couple quick steps. Did we in your group? Okay, talk to me. No, it's gonna come up. 18, talk to me. How do we get a pair of sides congruent?
AB minus AE is congruent to DC minus FC.
Good, we're gonna use subtraction. Because you guys know, why is DC congruent to AB? That's the first thing I'm gonna put in my proof. DC is congruent to AB. How do I know that's true? Going back. Why are those two segments congruent? 4. There you go, Via. Now your time to shine.
So what you can do.
Don't screw it up. I just want to know why they're congruent.
I can screw it up on purpose if you want.
Why are those sides congruent?
Okay. AB minus AE.
No. No. Why are DC and AB congruent? That's all I want to know.
Parallelogram implies opposite sides are congruent.
Thank you. Opposite sides congruent. Now I can go back to Adrian's idea. Hey, let's subtract them. Correct. AB minus AE equals DC minus FC. Subtraction, substitution. Everyone good for where we are in the proof right now? I have one pair of opposite sides congruent. Okay, this really tells me we know what's going on. At this point in the proof, what else would I need to do to make this into a parallelogram? You have one pair of opposite sides congruent. What else could you show that would make it into a parallelogram? There are two things right now we could possibly do that makes this into a parallelogram. Romeo, one thing.
That the same sides that we proved congruent are also parallel.
Special case. The sides we just proved congruent, DF and EB, are also parallel. We could do that. Or what's my other option? That would make this into a parallelogram. If I already have these two congruent, what else would need to happen here? Carter got something.
You can make it into a parallel line.
What?
Well, if they're parallel line.
What?
Oh, you just said that. Oh, never mind.
Yeah, the congruent sides would have to be parallel. I got that. We got that covered. I'm looking for another idea. Callum got something?
The other two sides congruent.
DE and FB would have to be equal. Yeah. So these are your only options right now to do. Both can be done. But I'm going to force you to do one way because I want to introduce a new theorem. Just so everybody knows, to get these equal, you would get the triangles congruent and say CPCTC. Okay, that is doable. You can do that. I don't want to do it though because I want to show you a new theorem. But everyone good. To get these two sides congruent, you prove the triangles and say CPCTC. All right, here's what I'm going to do with you. Let's prove those same sides parallel. How is the question? Got a quick question for you before I go back to that proof. These two line segments I just drew up on the board are what? Are those tiny pieces parallel?
Yeah.
Oh, they are. How about those pieces? Yes. So because the whole things were parallel, isn't any part or piece of them going to be parallel? Why do I ask you that? Go back to the proof. Other than being congruent, what else do you guys know about side DC and side AB? I know they're congruent. I have that already. They're also what? Parallel, because it's a parallelogram. DC is parallel to AB. Parallelogram implies opposite sides parallel. And do you see where I'm getting at now? Because they're parallel, what pieces should also be parallel that we need? DF and DF should be parallel to EB. Does everyone see that? That the pieces of DC and AB should also be parallel. And here's one of two new theorems you're going to have today. Ready? What makes those pieces parallel? Parts of parallel lines are parallel. Parts. So if you want to make the smaller pieces parallel, I got to use the word parts. I'll go in reverse in a second, but it's parts of parallel lines. All right, do I have a parallelogram now? Do we have a parallelogram or do I need to do more work? All right, we got it. Finally, step 7. EBFD is a parallelogram. I'm going to ask somebody why here in a minute. EBFD is a parallelogram. Please do not say special case. Why is this a parallelogram? Look at what we just did. Oh, we got some special cases in here. All right. 3. Jackson. Why? What did we just do? We proved. Yep. A pair of opposite. Got to have the word opposite. That's huge for me. Pair of opposite sides congruent and parallel implies a parallelogram. All right, so you guys have some time to practice. Let's go over the two theorems here. One we already did, which is if the whole things are parallel, so are the parts. Parts of parallel lines are parallel. Let's say those are parallel. Are those full ones parallel?
Yeah.
Okay, I don't want to use parts though, right? Because the parts are. So what do I use instead? I use the word extensions. Extensions of parallel lines are parallel. So if you're getting longer, you want to make it extensions of parallel lines are parallel. And yes, you can go right to the next page and get going. Work on it within your group. You guys have been talking to each other here for the last 2 days. Come on, get going. Might as well go question by question with each other here.